In this lecture, we'll take a look at the second approach to build a Docker image using Dockerfile. A Dockerfile is a text document that contains all the instructions users provide to assemble an image. What is an instruction? It can be, for example, installing a program, adding some source code, or specifying the command to run after the container starts up, and so on. Docker can build images automatically by reading instructions from a Docker file. Each instruction will create a new image layer to the image. Basically, instructions specify what to do when building the image. Let's go ahead and create a Docker file. A Docker file must not have any extension. It must be named as Dockerfile with capital D. The Docker file gets created. Let's open it up. We add our first instruction. From instruction. Docker runs the instruction in a Docker file in order. The first instruction must be from to specify the base image from which you are building.
Here, we just use Debian Jessie as our base image. So Debian Jessie is the argument for the from instruction.
The instruction is not case sensitive. However, convention is for them to be uppercase in order to distinguish them from arguments more easily. Let's move to the next instruction. Run instruction. Run instruction will specify a command to execute. It can be any commands you can run in a Linux terminal. Here, we do apt-get update first. Then we install git. Make sure we put -y option, because we won't be able to answer the prompt. Next, let's install vim as well. Now we have our Docker file ready. Just save the file. It is time for us to start building the Docker image. We have a new command to learn. Docker build. Docker build will build the image using instructions given in the Docker file. Here we type Docker build. Docker build takes a -t option to tag the new image we're building.
As I did in the previous lecture, I'll tag the image with my own repository name, jameslee/debian.
Docker build command also requires a path, which is the path to the build context. The path specifies where to find the files for the context of the build on the Docker daemon. For example, if we would like to copy some source code from local disk to the container, those files must exist in the build context path. Remember that daemon could be running on a remote machine, and that no parsing of the Docker file happens at the client side. When the build process gets started, Docker client would first pack all the files in the build context into a tarball, and then transfer the tarball file to the Docker daemon. What's more, by default, Docker will search for the Docker file in the root directory of the build context path. If your Docker file doesn't live in the build context path, no worries. You can tell Docker to search for a different file by providing a -f option. Here, my Docker file is at my current directory, so I can just use the current directory as the path. Now, we hit enter to start the build process. Let's go through the build output to get a better understanding about how Docker is building the image. First, it outputs sending the build context to Docker daemon. As we mentioned before, now the Docker client is transferring all the files inside the build context, which is my current folder from the local machine to the Docker daemon.
Step 1. From Debian Jessie. That is the from instruction.
As you can see, Docker is going through the instructions in the Docker file. Then step 2. Run apt-get update. Docker is executing the run instruction. It says running in, followed by a container ID.
What happens is that Docker starts a new container from the base Debian image and is executing the apt-get command in the container.
Now, when step 2 is about to finish, it prints out removing intermediate container and followed by a container ID. You might have already noticed the two container IDs are exactly the same. So Docker spins up a new container and afterwards just removes it. Let me explain to you what is happening here. Docker daemon runs each instruction inside a container. A container is a writable process that will write file system change to an image. In our case, it installs a program. Once Docker has written changes to the image and committed that image, Docker removes the container. So, for instruction, Docker creates a new container, runs the instruction, commits a new layer to the image, and removes the container. Basically, containers are ephemeral. We just use container to write image layers, and once they're finished, we get rid of them. Images are persistent and read-only. Let's continue digging through the output. Now it says step 3, apt-get install -y-git, and followed by a container ID. What happens is that at the end of step 2, Docker committed our container as a new image. And it starts a new container from that image for the next instruction. Now it is installing Git. When step 3 is about to finish, it is repeating the same process to commit the intermediate container as a new image and remove the container. Let's move to step 4. It says run apt-get install -yvm, and Docker is executing the command in a new container from the image it committed in the previous instruction. Once all the steps are finished, the build completes successfully. Let's run Docker images to make sure the new image is created successfully. As we can see, the image we just built is tagged with latest because we don't specify a tag when we run the Docker build command. The new image we created is about 250 megabytes.
The base Debian image is only about 125 megabytes.
The new image almost doubled the size of the base image. So the extra layers we added by installing Git and Vim are about 125 megabytes. That's all for this lecture. I'll see you later.